Okay, so this is section 3.2. Part 1, this is your first assignment. We're going to start talking about dividing polynomials. And this section is something you're going to be dealing a lot with as we go in. Before we do that, let's talk about just general long division, which you guys have probably forgotten how to do. So 26 over 7 can be written as 7 divided by 26. You should remember this from elementary school. So 7 will go into 26 3 times. 3 times 7 gives me 21 without going over. And I'm left with a 5. This is my remainder. So what 7 divided by 26 is going to be 3, which is what I got up here, and 5 sevenths, which is my remainder by the denominator that I had. Okay, let's look at a slightly different way of doing this then. Let's do divided by 7. Which can be written this way, 7 divided by 1, 1, 1, 5. So I can't put it into that one, but I can put it into 11. It will go in, 7 will go into 11 one time. 7, I subtract it, I get a 4. Then I bring my 1 down. 7 times 6 is 42, so that's too much. So we'll go in 5 times, then I subtract it, and I get 6. And then I bring my 5 down. So 9 times 7 is 63, so that looks good. And I can't do that. That's what I have remainder. So there is my remainder. So that number right there equals to 159, what I have on top, plus 2 over 7, which you're used to seeing written as 159 and 2 sevenths. Okay, we're going to do the exact same thing, but with polynomials. This looks scary, but it's the exact same kind of idea. So x squared minus 6x minus 8 over x minus 4. So we rewrite this, and we're going to do long division on this one. I'll have x minus 4, and then I put this inside, so it's x squared minus 6x minus 8. Now you want to check this guy right here. You're always going to want to write this from highest exponent to lowest. And if you're missing an exponent, like an x squared or an x, put in a 0. And I'll show you how to do this here in just a bit. So here we go. Now this really looks scary, but it's not. Just take a look at these terms first. X squared and x. So, just like before, how many times x squared? And the answer is x. X times x is x squared. And that's what you do. You multiply. You want to find it so that these two numbers multiply out to give you that number. In that case, x squared. Then I multiply it by this one. Now, when you're finding what you put here, all you're worried about are just these two terms. You ignore this other stuff for now. Now that I've got this, so I'm going to have x squared minus 4x. And then like on the other one, I'm going to subtract these two terms. So x squared minus x squared is 0. Negative 6x, negative and negative makes that a plus. Negative 6x, that gives me negative 2x. And then I bring my negative 8 down, just like we did with numbers. So now I need to figure out how many times this will go into this. Or you could think of dividing this into this. And you'll find what you have is negative 2. Negative 2 times x will give me a negative 2x. Then negative 2 times negative 4 will give me a plus 8. Then I subtract those two terms. Those go to 0. Negative 8 minus 8 is negative 16. And that right there is my remainder because I'm out of things to bring down and divide. So what we do now is we come back in and look at this thing. That's my remainder. So just like before, the stuff I had on top of this so I'm going to have x minus 2. That's from this. And then it will be plus my remainder over this. Now because that's a negative, so it will be minus 16 over x minus 4. And that's what you get when you leave out on this thing. Okay, so now let's take a look at the same type of problem, but we're going to do it a little bit differently. I'm going to deal with this same problem here, but I'm going to do what's called synthetic division. Now, synthetic only works if your denominator must be in a form of x with a coefficient of 1 plus or minus some number out here. If you've got anything other than x plus a number or x minus a number, you cannot use synthetic division. Now the reason we do use it is it's a little bit less painful. And you're going to have to know how to use both of these. So what we do on the outside, I just take a look at this term right here, and I change its sign. So since that's a negative 4, I write a 4. Now inside, I only write the coefficients. Okay, so the coefficients of this thing are 1 for my x squared term, negative 6 for my x term, and negative 8 for my constant term. Okay, and I got those just from looking up here. Okay, so what we do here now, then, first thing you do is you bring this number and write it down there. That was hard. You just copy it down. Then you multiply 4 times 1, which is 4. Write it up here, and then you add these two. So negative 6 times 4 is a negative 2. Then I multiply these two numbers. And if you look back, you'll see this sort of correlates with what we did over here, without all the little x's and minuses and all that in there. So 4 times negative 2 is a negative 8. I add these up, I get a negative 16. There is my remainder. Okay, so the question then is, you notice we got x minus 2, and look what we got here. But the question is, what power of x do you put on these things? Now, if you remember, what I have up here is I had a quadratic on top, okay, where the degree was 2. On the bottom, I've got a linear, that's divided by a linear, where the degree equals 1. So the resultant is going to be the difference between these two, which is 2 minus 1, which is 1. So the highest power of x I'm going to have is 1, and that will go in with this term. So we're going to have 1 times x from here minus 2, which looks exactly like what we got here, and it is. Then minus my remainder over my denominator, which was x minus 4. And that's synthetic. Remember, synthetic only works if you have something which looks like this, coefficient of 1 for your x term. It can't be anything other than x, can't be x squared, and you're adding and subtracting some number like that. So let's look at another example here then. And let's take a look at x cubed minus 8x plus 2 over x plus 3. And I'm going to do this thing both ways, both long and with synthetic. So the first thing I do is I do an x plus 3, and then I check my terms. I've got a cube, so I'm going to have an x cubed. Now I should have an x squared, but I don't. So I put 0 x squared, which gives me 0, minus 8x plus 2. So x cubed over x gives me x squared. I multiply these two, gives me x cubed plus 3x squared. Subtract them, gives me negative 3x squared. X will go into that, negative 3x times. So I'm going to end up with a negative 3x squared. Oh, and I forgot to bring my minus 8x down. And then I multiply this by this, give me minus 9x. That should be a squared, by the way. Subtract them. Those go to 0. Negative 8x plus 9x gives me an x. I bring down. X will go into x one time. 1 times x gives me x. 1 times 3 gives me a plus 3. And I've got a remainder, I subtract them, of negative 1. So what I end up with then is, from the top, x squared minus 3x plus 1 minus my remainder of negative 1 over my denominator, which was x plus 3. Okay, so now let's do this with synthetic. Same problem, but using synthetic. Okay? So I take this number and change its sign. And I pick up my coefficients. 1. I do not have an x squared term, so I put a 0. Minus 8 and 2. Bring this number down. Negative 3 times 1. Add them. Then negative 3 times negative 3 gives me a 9. Add them. I get a 1. Negative 3 times 1 gives me negative 3, which is a negative 1. So there's my remainder. And the thing to do is, what do we do here? So I've got a cube over a 1, which means I'm going to have a squared term. So it would be 1 times x squared minus 3x plus 1, and then minus 1 over your denominator, which was x minus 3. Okay? And you can do the same kind of thing. I'm not going to work this through, but if you take a look at x to the 6th, cannot use synthetic on this one because I've got an x squared. You also notice you're missing x to the fifth, x to the third, and x terms, so you have to insert zeros into those things. So my last note, when you take a look at it, piece of x is the stuff inside the division. Or it's the numerator you're originally starting with. And you're going to see these terms show up in homework. D of x is the denominator, or it's the stuff that's outside. Q of x is your quotient, is what's on top when we do these. And R of x is your remainder. So what happens is I start with some polynomial. Or my piece of x, what I had on top, is going to be equal to what I divided by times what we got on top after we did the division, plus my remainder. And this is exactly equivalent to what we did with numbers. So for instance, we say we started with x to the sixth. Now let's go back up and look one we did. When we did x to the cubed minus 8x plus 2 over x plus 3. We have x to the cubed minus 8x plus 2 equals, that's my denominator, x plus 2. If you go back and refer to your notes, what we ended up with on top was x squared minus 3x plus 1. And then I had a remainder was minus 1 over my denominator, which was x plus 3. And so that is how you rewrite the original polynomial.